We are focusing on different technologies and do all kind of things there. Sorry, I'm a bit tired. I just moderated the circle. Exactly. So we are running different events like this ones and others. We also have office space, so whoever is looking for an office, we have different seats here. Also afterwards, if you want to, you can just walk around. I can also give you a little tour if you're interested, and I'm happy to answer any questions that you have. What are we doing in the DePIN community specifically? We have different DePIN days, we're calling them. DePIN days always consist of a DePIN circle. That's a private roundtable. We just did one before, also on decentralized sensor, and then this DePIN circle are followed by the public DePIN.Sparx, so where we are here now. We have other upcoming DePIN circles and sparks. The next one is on decentralized energy. This is in 2 weeks. And then we're also planning on AI later in the year. And what is also super exciting, we have a DePIN unconference coming up. This is in September. We will have an academic track where you can also submit your papers. So if anyone is interested in that, you can also talk to Mark Ballandis. He can send you the link. And anyway, if you're interested to participate in the DePIN unconference, please reach out to me or also to Mark Ballandis, and we are happy to give you more information about that. This is just an example of an unconference, just in case you have never heard of that. This is for DICE. We run this in March here in this room, 150 people. And we are planning to do the same with a DePIN topic. And as I said, we also have these DePIN circles. This is actually from last time, from the one in decentralized energy. We usually do this there in the front. And that's it from my side already. If you want to join any of our upcoming events, please scan our QR code. And with that, I would like to hand over to Mark Ballandis for his first keynote.
Thanks, Viola, and very big applause. Maybe also one more time for her. Like she's like facilitating everything here. Woo! Okay, not there yet. Okay, I will try to make it quick. So actually, I want to talk about some challenges in sensor DePIN, and we even touched them today. But I know that there are some people not so aware of DePIN. I will give a very quick recap what it is, like briefly. In our last event, I already did it more extensively. So with every event, this intro to DePIN will become shorter and shorter until it's just obvious what DePIN is. So let's start. So DePIN stands for Decentralized Physical Infrastructure Networks. There were projects before, for example, like Power Ledger, who are also here in the room, which were like operating in this domain, but kind of it became famous through Helium. Like Helium is one of these DePIN projects. They are blockchain based. And what they did, they used token incentives to make people place physical infrastructure devices, like assets, so like kind of hardware. Yeah. So they made people buy hardware to place them and then connect them together. And they used token incentives to do this. So that's kind of the main takeaway from DePIN. Basically, DePIN's leverage crypto economics, which are these token incentives, decentralized governance, and also the properties of the blockchain, like immutability and some other aspects, to build physical infrastructures. And DePIN is Helium is quite successful. So they're starting to collaborate also with larger real-world industries like telecommunication companies in the US and in Mexico. So when some people see DePIN as a step of crypto out of the digital realm into the physical world and potentially facilitating real-world adoption. Okay, so it's a new vertical. For some people it's not new, for others it's very new, but there are already quite a few projects building in the space, over 500. It's already a year old, this slide. So it's something which is happening right now. So blockchain is not just DeFi, there are also other things going on. Last time I was talking basically implicitly about the definition of DePIN, and this is like kind of a capture, like a repetition of it. But DePIN kind of are made of these three parts. Yeah, so it's all about physical assets. Yeah, so like kind of there's these physical elements to DePIN projects. Then you use token incentives to build out the supply. So you incentivize people to build the supply of a network. And then these DePIN projects, they're kind of these three-sided platforms. So today we discussed a lot about it. But what is meant by three-sided platform is that you have a supply side. So for example, in Helium, those who maintain these physical assets. But then you have a demand side, people who are interested in the service. These are different people. And then you also have entities building out the service. And so you have kind of these three stakeholder groups, and it gets quite complicated because you have Web3 people involved, but also people who have not heard much about crypto at all, and maybe don't even like tokens, who kind of are customers of these systems. So there are a lot of complexities involved. And one can even go deeper in the definition. Messari is like coining the term, like I hear someone from Messari, like Mihai will also talk later. You can divide these DePIN projects further into kind of digital resource projects or physical resource projects. And what I like, kind of location independent and location dependent DePINs. So what does it mean? It's like kind of like fungibility with a token. So is it important that you have a physical asset, that this asset is placed at this location or not? So you can think of weather stations. So you can build a network of weather stations, and kind of capturing weather data from a particular location is very unique, because if you go 10 meters on, there might be a different microclimate. So you cannot just replace one weather station with the other. Whereas when you go to compute networks, so maybe a network which is connecting GPUs, it is not so important if a GPU is running here or 10 meters further down. So kind of these assets become replaceable. And when we come to these, to the topic of today, to these decentralized sensor networks, kind of they are all location dependent. Yeah, but there's also other aspects to DePIN. We are not looking into too much detail today. And now I want to, in the last 2 or 3 minutes, quickly touch the key challenges in DePIN. And one can say that these sensor DePINs, they kind of connect to this participatory sensing domain, and we will also have Sashit later talking about it. So one can build these sensor networks in a participatory manner without token incentives. And DePIN share some of the challenges from these traditional approaches on data quality and reliability. So the sensor can deplete over time and they can spoil. Users can contribute data and maybe at some point stop contributing data. So there's a lack of motivation sometimes. There are privacy issues and also cost in deploying such a centralized infrastructure. And DePIN is kind of addressing some of these problems. So like these lack in motivation and the cost aspect, they basically use these token incentives. But because now DePIN are incentivizing people to contribute data, you have completely new attack vectors. Yeah? So people trying to start gaming the system, maybe to get these rewards. And then you have threats on the device level, network threats, and in the end also environmental threats. So if you have a sensor, people can start manipulating the environment, and if your tokenomics is rewarding such a behavior, then people will do it. Yeah, so it's like kind of a challenge. And what we have like elaborated in this reference work is like that purely hardware and software approaches are not really fixing this issue. So in the end, it becomes game theoretical and behavioral, and there might need to be the case that it's more on that level to address these issues. Though there are solutions, and Mel will talk about some aspects to also how to do it in an algorithmic manner. I'm very much looking forward to it. Okay. But I think in my opinion, the main challenge actually in DePIN, what people don't want to look at is this aspect of viable business models. So in this sensor domain, it's a lot about collecting data actually. And what we have seen so far is that data by itself is not really valuable. So not many people want to pay for data. There's a theoretical argument that actually we don't even have the processing power to process all this data. So there's some issues. So by just collecting big data, we are not adding any value. But very practically speaking, from the weather domain, for instance, I know that making people pay for weather data is very hard. Yeah, so everyone says they need weather data, but no one wants to pay for it. And I've actually seen very few existing data markets to which a DePIN could serve, or like kind of could develop a product market fit. And if I look at it like for sensor DePINs on these business models, I see the standard, or the most easiest way to do is basically not to address a market. So simply building out the supply side. Many DePINs, in my opinion, are doing it, but there's one famous one which is called entropy, which explicitly says they're only focusing on the supply side, and through this they have a perfect product market fit for the DePIN community. But that's like kind of, the standard thing. Then a DePIN project could go into an existing data market, if there's one existent. And we know from the GNSS space that actually there are instances of data markets, and one of them is this GNSS industry, where Onocore and GeoNet is operating. But here you can have different approaches. You kind of can build like the Apple model of a business model, where you develop the hardware until the final product and you sell everything out of one hand, or you try to have it more in a platform manner, basically integrating different stakeholders, so like being more horizontally integrated. And then at YHI, what we think in terms is that in the end, because there are not so many data markets, one actually needs to go a step forward and have more like these intelligence services, or kind of use the data one collects, but kind of go the last mile. And I think that's a huge opportunity for DePIN projects to also go into this AI narrative. So that's on business models and challenges. These are just initial thoughts. So we also want to explore this much more. As Viola said, we're going to have an unconference in September. And for the researchers, there also will be an academic track, so you can also contribute papers. And it's also explicitly meant for people from the industry. So you don't only have to be like an academic institution. A lot of research is also happening in the field. So don't be shy, write it up and join us. And this will be an aspect of it. We're also thinking of having kind of booths with different, like kind of a fair, like a science fair with different DePIN startups, and then also have this unconference format. So like kind of an event where the agenda is driven by the participants. So that's what's upcoming. And with this, I will hand over to Mihai.
Applause to Mark for providing us a good intro, and also for letting us know what are the key challenges in sensor networks. So now that we know what are the challenges, the question arises, is DePIN and our decentralized sensors an area that is worthwhile investing in? And one question for you guys, raise your hand, how many of you have DePIN tokens, have invested? All right. So yeah, there's a fair amount of that. So we explored this question with VC Shop, 1KX, and we were thinking at actually how to value DePIN networks and also sensor networks in particular. And we were putting ourselves in the position of an equity researcher. And we've seen that, in the past, equity researchers were looking at price to sales ratios or price to earnings ratios. However, for DePIN or like for crypto, such a thing doesn't exist. So we were thinking how to improvise this, how to come to a price to sales ratio. So what we've done is we sampled the top 80 DePINs out there in the market. And we've looked at the mean fully diluted valuation of those. So that's essentially the market valuation for the token for all the tokens that are actually going to be issued for the whole span of the token life. And you can see it here with the blue line that actually we had a period of a hype in DePIN where we had relatively high fully diluted valuations. And in the recent years, we've seen that those valuations have gone down. Also, Mark mentioned just before that one challenge is to make people actually pay for the DePIN services. So what we've done is we aggregated revenue numbers for DePINs, and yeah, we plotted them in the green line. And what we can see is that recently the green line is growing, whereas the blue line is yeah, going down. So in our analysis, that means that price to sales ratio goes down, which makes the whole DePIN space more and more attractive. But the question is, how attractive is actually the DePIN space? So with the green line that we just plotted over here, we looked at 80 DePINs, and we noticed that the price to sale ratio went down over time. Whereas if we look at other sectors, for instance, at layer ones, we see that the price to sales ratio is relatively elevated and has stayed at the same level for quite a while. The same thing applies to layer twos. However, if we look on the bottom side, we see that especially we have DEXs in borrowing and lending protocols that actually have a much more affordable price to sales ratio. This is caused by the fact that especially DEXs or AMMs make shitloads of money out of trading fees, and we can literally see that in the ratio. So they are literally down, and they have been down ever since inception. Whereas for DePIN, we can see that they have become more and more affordable. However, not all DePINs are created equally. And yeah, the theme of today is decentralized sensors. So essentially in our sample, we had 9 projects in the decentralized sensor space. However, for the whole analysis, we used 80 protocols for which we were able to find publicly available data, both on fully diluted valuation, but also on revenue. And we see we were able to sample 25 projects with publicly available revenue data, and then the rest of 55 actually have a fully diluted valuation, but do not have public revenues out there. So we were thinking on actually looking at all these subsectors in part, and to see what is overvalued, what is undervalued, and so on. So when we decided to look at either digital resource networks versus physical resource networks, essentially we've seen that digital resource networks like decentralized compute with all the AI hype, they are valued around 3.5 times higher than actually physical resource networks. So if you compare a protocol that sells AI compute versus a protocol that leverages decentralized sensors, that one on the decentralized compute will be 3.5 times in average more highly valued. However, we can go even in more granularity here, and yeah, we can see that pretty much sensor data or like decentralized sensors are somewhere in the middle. So we see that the valuations for digital resource networks tend to be higher, but for physical resource networks, they tend to lag. However, we think that sensors or decentralized sensors are relatively well priced at these valuation points, and definitely you can find more value in the decentralized Wi-Fi, and this is a topic yeah, close to Mark's soul. All right, from here on, we were thinking of what are some other factors that actually influence or correlate with higher valuations. And one of the topics that is in every VC's mind is actually whether the protocols employ token burns. So essentially, for the tokens that you issue and that are being used in the microeconomy of a protocol, would some of those tokens be being burned or not? And there are various token models that are actually being used. And what we've seen is that protocols that employ token burns tend to correspond to higher valuation out there in the market. So they are hotter for VCs to invest in, and that this narrative that has been proliferated in the past actually has proven to be right. And yeah, essentially those protocols that do burns are more successful beyond the hype. All right. We also looked at whether the protocols or like the networks are listed on public exchanges, on major exchanges, and we were looking at whether those protocols are listed on Binance and on Upbit. And essentially, what we were able to see is that everything in blue that is listed on those exchanges actually tend to have higher valuations, and they also tend to have higher liquidity. So essentially, the liquidity depth is much higher whenever you're being published or whenever you're being listed on a major exchange versus on some decentralized exchanges. Of course, we have here several exceptions where although they are being listed, those projects exist for quite a while, and they didn't fly up on the current hype. But usually being listed in major exchanges helps drive the valuation further. All right, these are only a couple of slides that I prepared. These are part of a report, a series of reports that we've put together with 1KX. So if you're interested in reading the full report, drop me a line at TechMetrics or scan the QR code, and this is how you find me. And if you have any questions, shoot me up.
Yeah, so everyone please hold on to your questions until the panel. And next up.
Hello, everybody. My name is Christian, and I'm with Belimo. Just to put a bit of context, we are not really in the DePIN domain. We are deploying sensors and devices in commercial real estate, but we're not active on the blockchain. But of course, there's some use cases maybe that could be potentially interesting. There's some shared concerns, and I would just like to introduce you to what it is that we're doing, and maybe get a conversation started about this. I don't know if I have the power. Thank you very much. All right. If you cannot hear me, please let me know. So what it is that Belimo is doing. Like I said, we're in the HVAC industry. So HVAC is short for heating, ventilation, air conditioning. So we help that you're all feeling nice and comfortable in the building. And if you look at the roof or the ceiling and there's some orange boxes, there's a high chance that these guys are from us. We have this kind of orange trademark color. And as you can see, we have 3 different business lines. One of them is sensors and meters, and we do sensors for ducts, for pipes, outdoor air, room operating units, and so on and so forth. And also we are in the metering business. And then we also do devices that control airflow and water flow. You can see our devices, like I said, from kind of the roof, where we are involved in cooling, in the heating, in the basement. You can see our devices in the wall, in the rooms, on the ceiling, in the car park. So we're kind of all around in the commercial real estate, and that's what our customers are. So commercial real estate buildings, government, hotels, data centers, hospitals, airports, and so on and so forth. And like I said, we equip all of those with sensing devices. The company itself was founded 50 years ago, in the stock market since that is 30 years ago. And we ship about 10 million products every year. And revenue-wise, we are close to reaching 1 billion Swiss francs this year, probably, if we get very lucky and no crisis happens. So let's cross our fingers. That's our leadership team. It's a very traditional Swiss KMU. And we've actually been in the sensing domain officially or unofficially since 1984 with our first sensing device. And what's also very interesting in how the company is kind of operating, we actually know what we can do very well, and we also know what we cannot do very well. And we try to look for partners that can do things better than us. So a lot of our cost basically is generated with our suppliers. And then we basically take pre-manufactured parts. We assemble them, calibrate them, and then we customize them. So that's an open invitation to, if you feel like you have anything to contribute that could be useful for us. I think we are not trying to run away with your great idea, but we are very happy to engage in partnerships with our suppliers, right? And just to give you an idea of what kind of services we're offering, we talked about the smart metering. This is kind of our, I would say, most advanced IoT stuff, and I will also tell you why this is the most advanced one. So we have two types of communication protocols that we kind of rely on. This is NFC, which we use to basically commission the devices to tell them where they're sitting and what they're supposed to do and whatnot. And then we also have a cloud that is connected to our metering devices. So this is a permanent network connection. And the other devices that we have, as you can see here, they don't really have a permanent connection. So this is all somewhere in between. So what does somewhere in between mean? You have to understand that roughly 98% of the investment that's being done in commercial real estate is in old and existing buildings, right? So you do renovation and the rest is only new. So only 2% of the buildings every year are new. So the average building is quite old, and that means they probably rely on analog infrastructure. So they have analog control signals, analog output signals, and nothing's really digital, right? So that's a challenge, because you have to replace something that is analog, and to make that digital is one concern. And also people like what they're used to. So the industry is fairly slow. Which of course tells you, well, if you want to do something new, maybe Wi-Fi is a technology, maybe LoRaWAN is a technology, could be interesting. But overall, things are fairly slow in our industry. Nevertheless, what are potential use cases that I see or envision, right? Of course, we talked about the incentivizing participation, right? I mean, this is how the, I think Mark talked about helium in the beginning. It's a typical example. There's one that is now emerging also for the HVAC industry. There's one about decentralized data and ownership monetization. Can you monetize HVAC data? For me, this is a bit of a challenging one, because you have to understand how the industry works. So there's a person that wants to build a building, that's an investor, and he asks somebody to basically design and commission the house. Then there's contractors, there is people who then eventually come to us, they buy our equipment, other people install it, and then somebody's renting it out, somebody else is using it. So there's really a lot of people in that whole value chain, and who really owns the data and who can monetize it. This is a bit of a very tricky one in the HVAC industry. So for me, is a kind of very complex ownership setting. So I'm not sure if this is really something that in the HVAC industry is happening. Something that I see potentially is trustless data verification. We are in a time where people are incentivized to achieve certain standards in terms of indoor air quality, in terms of energy consumption, in terms of maintaining certain properties about the HVAC system. And in turn, they receive tax benefits. And we used to be in a realm where people simply had to verify that they have installed something very nice. But now there's first local incentives where you have to constantly provide that sort of data, and also to verify, right? So of course, this is then, I think, a primary application where you can think of putting this on the blockchain. Of course, goes with the idea that there's a governmental agency that provides those tax benefits, and you have to kind of convince the governmental agency into something decentralized. So interesting challenge, but I think that's probably something that can work, and I'll go into that a little bit more into detail. And a fourth use case is the interoperability across different stakeholders. So if you think there's different people in the house that they have different kind of sensors or different needs, yeah, maybe there's a lot of things that you can argue that you can have smart contracts, or that different things share data. But in the commercial real estate, the person who does the planning is usually a once-off organizational effort, and whatever's in there is in there, and that you kind of bring in your own system, your own data. I think this is going to be a tough one. So summing this one up, incentivizing participation maybe is something that I see in the HVAC industry. For us, ourselves, not so much, because our customers would, I don't see it. The trustless data verification probably could be something super interesting. And giving you one example that I stumbled across in at a conference some weeks back. I don't know, many of you have probably heard of the Planet Watch token and network and so on and so forth. They were looking into providing air quality data for PM, so that's micrometer sized particles. The project kind of had a good start, then went a bit bumpy. I think now they're being taken over. And this company is kind of doing a similar thing on the nanometer scale, except that they kind of own the whole thing, or they want to. I don't know how active they are, but again, this is something that we're seeing. And the problem here is a little bit the same, right? It's a chicken egg problem with the nanoparticles. So the first thing is nobody knows the concentration because there's no sensors, right? So then we need to put the sensors to get data, and then we know, okay, there's maybe a higher concentration. And then when you know there's nanoparticles, then maybe people start looking into, okay, there could be a potential health problem, let's investigate. And then once there's a health problem and that's verified, then we probably come to the idea, okay, nanoparticles are maybe bad, so maybe we need to do something and monitor and control. But this is a very, very, very long shot for a technology that is quite expensive as well, but people are looking into that, also in the HVAC industry. And then I kind of was diving into this a little bit in the beginning, the trustless data verification, right? Like I said, companies and building owners and investors are incentivized to meet ESG standards, air quality, and so on and so forth. And maybe there's some legislative and regulatory support and local incentives, decarbonization laws, and so on and so forth. Just some examples that kind of pave the way, right? But this, like I said, is a bit of a long shot, but it's something that I definitely see as a potential application. But then, of course, who's generating the data, who owns the data, where's the financial benefit, how is this being paid back, right? This is a bit the problem or the question to address. With that, I'm actually already at the end. I wanted to keep this very short for the sake of discussion. If you have any questions, you can please come to me later and we can follow up.
And next up.
Thank you. Hi, everyone. My name is Sachit, and I'm based at ETH Zurich. So I'll just try to follow up from the last presentation, because I'm also not talking about DePIN, but I'll talk about the connection between sensing systems and DePIN. And like Mark said in the beginning, I'm mainly looking at distributed sensing systems, like big IoT infrastructures, building them from bottom up. And what I look into is like how we can use these devices, these edge computing, to create these systems, which can provide more value to every stakeholder. It can be a citizen, it can be a community, an NGO looking for it, or even policymakers. So I'm looking at different mesh networks, different topologies, looking into MQTT, LoRaWAN, like how to have low latency and easy infrastructures to do it. But the idea of building them is building an open source ecosystem so that we have a development process where everyone can build these sensors, because nowadays it's so easy to get like off-the-shelf sensors that you can easily assemble it, use DIY method, then create one. Of course, these are cheaper, not the industry-grade sensors like 10,000 pounds or something like that, but still you can get enough data to have them at scale so that you can get more fine-grained and more granular data that you can use with. And my main area of interest, or the research point, is environmental sensing. So I look into air quality, water, noise, temperature, humidity, etc. And the way I look into it is that we can create a system which is cost effective, which can provide you real-time data, which can be high resolution, and the end goal is to create like more urban resilience. I remember in the beginning someone was talking about these earthquake monitoring. So I think it's similar to that. The idea is to have systems that can provide you real-time feedback so that you can make decisions before anything, any disaster or any issue happens before. And I want to jump quickly to a real-life example of the project, one of the projects I was working on. So this is like not a beautiful day in Taipei. So if you have ever been to Taipei, it's a beautiful city, but again, the country suffers a lot from air quality problems. So it's a lot of smog and a lot of issues. So we started working on this airbox project, which started as a research project. And the idea was to create these different low-cost sensors to enable people to monitor air quality at scale, which means even a family, a student, or anyone, they could just use these sensors and build it. Here you see different designs because we realized in the beginning that you cannot have one solution or one design for every stakeholder. So we had to figure out like what kind of different materials we were using, what sensors we were using in terms of data validity, calibration, and all these factors to create a design specifically for different end user. Then we made it open source. So from the hardware to software to data, we wanted to keep all the layers open so that it kind of empowers any stakeholders to contribute to this and also build it and contribute to the entire network. One of the good things while doing this was that we didn't stick to only the research community. So there were the companies, for example, Edimax. It's one of the companies that started building commercial grade sensors, but also they started contributing more towards different technologies that could be used to build more robust sensors. And in the end, we engaged all different stakeholders to create this air quality monitoring system in Taipei. The idea was to have open source hardware, open source software, and open data to have Internet of Things and citizen science. So for you, for those who don't know citizen science, it's more like you can relate it to crowdsourcing, but it's not only related to crowdsourcing because you're also asking them to look at the data to have more granular insights and contextual knowledge so that it's not just raw number, but rather something more valuable. And the end result of this was that we started in 2015, so we had 77 stations. These are the official EPS stations in Taiwan. And by the end of 2023, we had almost 12,000 sensors that were deployed throughout the island, not just from a research project or something, but we had people from community, from policymaking, hobbyists, even DIY community who were building these sensors and who were taking care of that. One question that probably would arise right now is like so much data, how do you make sure that the data is reliable? So what we did was we created some machine learning algorithms to run it on the edge system where they could do spatiotemporal anomaly detection with the nearby sensors. And the Taipei government, the Taipei city government, they also decided that once the project finished, because it was a research project, they integrated the project within their smart city initiative. So there's always a chance that when the funding runs out, the project dies. But in this case, because we somehow integrated the key stakeholders right from the start, so it was easy and possible that it got integrated within the official system. And once we had enough data, we also started looking into how it could affect different things. For example, the data itself is super valuable, so we tried to understand, like how we could use, for example, a route navigation system where it allows you to have more healthy routes, more learning data for people. Then, like there's a lot of air pollution which is caused by incense burning. So we worked with the temple organizations. It was not easy because, religion and technology doesn't go, easily side by side. So, but I think the idea of having open system where you knew how the data was made, how the sensors worked, and whether the data was reliable or not, people started trusting it. And one key insight from all this thing was we didn't incentivize at that point. So the motivation was very intrinsic, like people wanted to do it because they could relate either, they wanted to understand more or they were just interested. So that was a lesson that we learned there. And I wanted to understand how does it work in Switzerland, So we started looking into, Swiss system. The problem with Switzerland is, or not the problem, actually Switzerland is very clean, so it's a good thing. But then the problem is there is a lack of information. So what you're seeing is like these 5 spots are the sensors that are there in the city. And like this is just a very estimated idea that you can see the population, that's a heat map. So there are only 5 sensors covering the entire Zurich city. So there's a lot of potential of what can be done with these sensors or these kind of infrastructure. So we started looking into what we should do here, and we started this small initiative called Know the Air You Breathe to understand how much people know, first of all, about environment, and how much they actually want to be involved in, if they are allowed to or if they have the resources. The first thing we understood was people had this misconception that Switzerland is like super clean, cleanest city in the cleanest country in the Europe. But I don't know if how many of you know, but the indirect way of measuring how bad the air quality is, like cigarettes per day. And in Switzerland, it's like 7 per day, which is still less than any Asian country, but still it's a lot. So when you tell people that you are not smoking, but you're still feeling the pressure of that on your lungs just because of the environment, you know, they start caring more. So we created this low-cost infrastructure which allowed people to use it, and it also helped us to create this shared understanding. One interesting outcome of this was because we were doing indoor air quality monitoring, so people wanted to know more from the city of Zurich. So they wanted to ask whether the rents that are decided for the apartments actually consider air quality or not. And I think in most of the cases they don't. But then I think once people were aware, they wanted to know more. But then we also realized that to sustain the engagement, we needed more ways of doing it. And I think that's one of the things which I realized while talking to others, that incentivization can be a key, because while we have a lot of challenges, you know, data quality, assurance, participation and all, I think with DePIN in general, I think there are ways in which you can find the right incentivization for the right task. And not just for, you know, having more engagement, but also for security processes, for data validation, and also for governance. And here, by governance, I mean by having the real guidelines or protocols which can be more standardized and more approved and well decided. So that would be it from me, and I would be happy to have any feedback later and discuss more with you guys. Yeah, thank you.
Thank you so much. And last but not least, it's Mel and Daniel, actually. Sorry, I missed you before. Who goes first?
I'll start. Yeah. Hello, everybody. Can you hear me? There we go. So my name is Mel McCann. I'm with the Aegis Alliance, my colleague Dan, and we're here to talk about trust. So we started this journey to look into DePIN. My background is I spent 4.5 years with Cardano. I was VP of enterprise technology, which was essentially trying to tackle the problem of adoption, real-world adoption for Cardano. I left because I wanted to look into the DePIN side of things, and when we started looking into DePIN, I should probably skip that. We noticed that a lot of people are connecting devices to these networks, but they're not ensuring that you can trust the device. And this is what we wanted to focus on. We wanted to allow people or enable people to connect devices to networks and then be able to trust that the computation that they're performing is valid, is verified. Okay? So, I'm going to start and talk a little bit about, you know, how we started our journey and going from low-level computation and proving that, and then Dan will talk about the next evolution of where we're going with this. So essentially what we do is we, at the lowest level, we don't use trusted execution environments. At the processor level, based on the opcodes, we use arithmetization to generate a mathematical model of the functioning of a program. Then we take that mathematical model and using function hiding functional commitments or function hiding zero-knowledge proofs, we wrap them up into a proof, essentially. But the first part is creating what's called a commitment. So a commitment then gets sent up to the blockchain, and then every other proof can be compared against that. So if you think about it from an IoT manufacturer point of view, if I'm creating 10,000 sensors, I only have to create one commitment for all of those sensors for that computation, and then every other sensor that is of that type will generate these proofs that can be compared against that. Okay? The reason we want to do this is we want to be able to understand that if you have an autonomous vehicle, if you have a sensor, if you have any computation that happens on a device, we want to be able to assure people that it's functioning as intended. There's 3 elements to this whole verifiable computation. There's the verified computation, there's the security element, which is the second part. So for example, if a program deviates off its natural course, for example, if you inject malware into firmware, we will be able to detect that. The third part is assurance. So if, because you, in advance, you create that commitment, and that's publicly available, afterwards, people can use that as an assurance level that the firmware or the program or the device has not been changed. So if you think about, for example, a car manufacturer that was fudging their numbers, if their firmware had a published commitment that had to be, you know, and then the proofs would fail, so that people would know that they had tampered with their firmware. So now, where we've applied this, so we've applied it to building sensors. We take the proofs, we stream them via MQTT to a custom blockchain. Our blockchain nodes can do machine learning on the data if we wanted to. But what we've applied it to is building sensors, essentially, and we've applied it to a hydrogen system. So this hydrogen company, Australia, wanted to be able to prove without a shadow of a doubt that their devices were working as intended. So that allows us to do that. So Dan, I don't know if you want to continue. Oh. This. Okay. So we also built a small temperature and sensor card to demonstrate this for people. So you can easily just press a button, and on ESP32 chip, which is common as muck when it comes to IoT devices, you can generate this proof without much overhead. We also did it with the Siemens 2050 gateway for the hydrogen company. So all the sensors controlling the flow of hydrogen, oxygen, and argon feed into that gateway, and then we use the arithmetization process to be able to generate a proof, proving that that device is actually functioning as intended. So, do you want to take it away? Sure. And
hey guys, as Mel mentioned, my name's Dan. I won't go into too much background, but security researcher generally is my background, from government through general cybersec and red teaming into decentralized technologies now. As Mel mentioned, I'm just going to go back a little bit back to front here. So on the back of what Mel's discussing in terms of the verified compute infrastructure, and obviously because of the integrations at the hardware level, we also kind of considered other ways in how to not just use it but make it available. So what we have designed and we're in the proving of the concept at the moment is a platform we're currently calling DePINity, the DePINity protocol. It's not necessarily a full DePIN infrastructure, but the verified compute is integrated at the hardware level again. So think of your server data center infrastructure. So then we generate a cloud architecture, which is familiar interface, familiar architecture, familiar use cases from what you're used to with AWS, GCP, and all the other things. Technically speaking, it takes on a bit more of a distributed architecture at the data center level, so think more like your DigitalOcean, so it's not all centralized to single proprietary data centers. It's kind of more co-located in terms of its design to give it that distribution. But ultimately, the mechanisms that Mel explained and described are implemented at that hardware level within the data center infrastructure, within the server infrastructure, meaning that you get verified compute on your virtualizations that are built from your nodes, from your virtualizations that are built from the physical infrastructure. So here, obviously, all virtualizations benefit from the the imaging of that verified compute mechanism. So obviously, the use cases for this are pretty wide-ranging. Anywhere where, like Mel said, we don't rely on trusted execution environments. We're kind of creating a new a new trusted execution environment, but it's verifiable. Not only is it verifiable, and with the zero knowledge proofs, it's attestable. So we can attest to the actual correct functioning of everything that's going on in that network. So if you imagine, you can use it for MPC nodes, you can use it for key management, you can use it for anything where functionality critical operations are taking place, validator nodes, and other kind of similar infrastructure, even for trading. So trading nodes. So there's quite a wide range of application for this. That's for the IoT side. What we also are in the process of implementing is AI agents to allow easy setup, easy configuration at the user end. So typically speaking, originally it's quite a cumbersome and complex operation to set up the zero knowledge proof architecture. But now whoever spins up a VM, whoever runs a node that's based on the zero knowledge verified compute cloud can integrate that based on their code. They can basically, as it says, you can import your code, integrates with the SDK, and it actually kind of creates your own verified compute node without having the intricacies of having to do it manually, which was previously the case with the initial IoT and industrial IoT architecture. And so, as Mel said, we've proven the concept on the industrial side and rolled that out to cloud infrastructure now. We're hoping to widen the use case of verified compute, and not just verifiable, but attestable for all operations running on those nodes. There are some other applications that we're working with. I don't want to go into too much detail with them because they're in works in progress. But certainly for high-value infrastructure such as telecommunications, we are working with a decentralized satellite 5G infrastructure platform. So we're looking at maybe two aspects, both for the cloud-based architecture for their 5G core network, but then also on the hardware level, so able to scale back their hardware overheads in terms of coming back from ARM architecture into RISC-V, for example, but we can on the actual satellites themselves, but we can then provide the added, we can scale down the weight and the computational complexity, but then actually increase the security and overall of their systems on the hardware level as well on the Cube satellites. So there's a great deal of applications for this, and we and obviously from the roots of the verifiable compute on the device level, and now bringing that up to virtualized services from our cloud platform. That's all.
I think the last thing to say is, it's essentially about trust. We have surrounded ourselves by devices that we implicitly trust. Perhaps we shouldn't. I think that as time goes on, AI is definitely eroding our trust because we can trust a lot of things for sure, and maybe we shouldn't. Maybe we should be able to verify the devices that we surround ourselves by, whether it's cameras, whether it's toasters, whatever it is, medical devices. I think that it's time that we start being able to trust them. So thank you very much. The toasters, yes. Come up and say hi to me and Dan afterwards. I'm happy to answer any questions. Cheers.
Thank you so much. Thank you. We are now moving on to the panel. So I would like to ask our speakers to come up on stage, as well as, where is he, our moderator? Here, as well as our moderator. We will also take questions from the audience. So get your questions ready, and I will get the presentation ready.
All right, how's everyone doing? Is anyone here that's just hearing about DePIN for the first time today? Like 1, 2. That's good. That's a good start. I have a long way to go regardless. I think 2 weeks ago I went to a SUI event in Lisbon. 0 people knew what DePIN was. I was like, man, either Swiss doing a really bad job or we have a lot of work to do still. So we're still early. I like to say that, right? But yeah, first I'd like to thank the organizers, Trust Square, for putting everybody together here. And it's been a really pleasure. Before this event, I actually had another thing that was happening in like more like closed doors. Everybody's trying to figure out what is the future of DePIN, what are the challenges, and it's super exciting to be in this ecosystem, knowing that there's so much work to be done, right? But my name is Daniel. I'm the co-founder of a company called Hotspotty. We're building a platform called DePINHub.io, which you can think about like CoinMarketCap plus DeFi Llama, but just focus on DePIN. I've been in the space, I think DePIN, the decentralized infrastructure, for a long time. I think like, I don't know, 5 years. And in crypto, 13 years. So it's been nice ups and downs ever since. But yeah, I'm gonna start talking about with these guys here. I think it's a bit challenging to do the panel as well because everyone presented. So all the questions already done. So also if anyone has questions that you'd like to ask, please just raise your hand. But yeah, from the presentations, there's a lot of actually questions that I would like to do. I'm gonna start with Mihai here. From the presentation that you did, the charts, investing in a layer 1, it says like it's a better investment in terms of like tokens, right? If you just want to focus on the return. And if you're not like me, that is just in crypto only for the technology, what would you say that is the case for people to invest in DePIN?
Yeah, so the case for investing in DePIN is, first of all, from a philosophical standpoint, DePIN is just a better system than centralized players. So if you want to be in some networks that are going to exist in 20, 30, 40 years, then this is time to plant the seeds. Other than that, as we've seen, DePIN valuations are becoming more and more affordable as the time passes, which means that many of these networks are actually here to stay. So I think this is quite a strong case for them.
Yeah, exactly. I mean, there's so many, I think, projects that are super early, right? And one thing that we realized by talking to founders and talking to so many projects is that DePIN is really hard. I think comparing, like, crypto is hard. But DePIN, I think there's an extra level of complexity that you multiply instead of just add. Because you have, if you're building a project that has the hardware, you need manufacturing, fulfillment, Web3, Web2. And what would you guys say that is like one of the hardest challenges of building a DePIN? I know that you're not building one just yet, but maybe pretty soon. And I don't know if any one of you guys would like to talk about one of the main challenges of building a decentralized infrastructure project. Any taker?
Yeah, I can go for it. I think it's the chicken and the egg problem. I think like many DePINs started with essentially issuing tokens to bootstrap some of the supply of the network in the hope of demand coming and buying those services. And I think the hardest thing to achieve is actually that demand coming. And we've seen only recently some DePINs actually migrating from Web2, from traditional businesses, having already demand and trying to decentralize and becoming actually a DePIN. That seems to be an easier route. So first of all, having demand and decentralizing later, instead of doing it the way actual DePINs have done it, not having any demand, but trying to bootstrap the supply. What do you guys think?
Yeah, maybe just to add to that from like our company's perspective, one of the biggest challenges is actually device security and safety and data integrity. And you have to kind of understand that the devices, if we deploy them to the field, they have a life cycle of around 20 years. So they're kind of in use for as long as that space is being used, right? And basically, if that device is used for monitoring, for billing, for, I don't know, obtaining certificates, then of course, after a few years, the security that was state of the art when the device was installed becomes obsolete very quickly. So there's a huge challenge to make sure that the data is not being tampered with. And what Mark mentioned, right? There's can be a lot of gamified approaches. Let's put it this way, in a nice way, but to tamper with the devices in the mid and long term. And for us, this is also a super difficult issue. And I think there was a good connection to you guys.
Yeah, for sure. Thank you. I think that, I mean, we've been exploring this for a while, and the difference between two conferences, I went to an IoT conference in London and then blockchain conference in Paris. And at the IoT conference, nobody knew what was going on. They didn't know about DePIN, they didn't know about any of this. And it was a problem, and I think it's an educational problem that these traditional industries, once they start learning about this option for them, they might start adopting it. But I think that there's actually, it's such a, I hate to say it, possibly a niche area right now that, you know, traditional industry doesn't even know what they need. And that's why I think platforms like this are fantastic, because it gives people the opportunity to share more about what they're doing in the DePIN space and hopefully connect with good companies and other projects. Yeah.
Yeah, well, that's exactly one of the reasons why we actually started DePIN Hub, right? Because like we started building like a SaaS product for like a one specific DePIN project, which called Helium, which was like one of the first ones actually that got product market fit. And then we started, okay, let's expand this for other projects. But then we got to this problem, like nobody knows what this ecosystem is. How can we try to help that? And 2 years ago, we decided, okay, let's build this aggregation platform to really try to teach the people into learning what is DePIN. Because what I like to say, that DePIN is the gateway drug to Web3, but we always need to actually still have a lot of education done. One thing that I like really makes me want to wake up in the morning and try to expand this ecosystem is can really change people's lives, right? Because you think like, oh, you deploy some sort of infrastructure that can be an idle resource that you have at home. For example, you have a Hive mapper, you put a dash camera in your car, and depending where you live in the world, that extra resource can really change your life. You know, like maybe you make like $50 a month extra, that can really add to the bottom line and can really make a difference. Plus, we're trying to really re-evaluate how infrastructure is built, and like we were saying, like you know, devices need to live for 20 years. We're still, this thing only exists for a few years. So it's a lot of work to be done. But the good thing is, like I said, it's exciting. There's a lot of work to be done. There's a lot of opportunities, and you know, being early means a lot of opportunities there as well. Anyway, I can rant here forever. I would like to ask a question for the DePINity. Nice. While you guys are building this, is something that most DePIN projects require, right? Not even just DePIN, just sensors in general. How do you think that, who's going to be the main customer of that data, and how you plan to make money from the project?
Which portion of it? Because I mean, we talked about two different sides. We talked about, you know, the sensor portion, but also the cloud architecture portion. So
both.
Okay. Do you want to talk about the cloud, and then I'll talk about the? Okay. So on the DePIN portion, what we're doing essentially, it complements, because people have asked me this. Does what you're doing, you know, is it competing with other DePIN projects? It's not in the slightest. It's actually a facility that every DePIN project can use, and that's something that we wanted. We're not trying to, you know, we're trying to support the whole DePIN area. Now, when it comes to where those proofs go, we have the ability to put them on other networks. We have our own Ethereum-based clone at the moment with custom nodes that allow us to do the machine learning stuff that people might want and all the rest. You know, and for the nodes, there's a license, and that's how we make money. So the cloud portion, tired, so is Dan. You want to talk about that?
Yeah. So I mean, on the cloud side, you know, fundamentally we want to kind of at least adhere to some kind of familiar infrastructure or mechanism. So, general subscriptions for however you pay that, whether that's in crypto or in
like a
fiat or
SaaS
whatever.
business, more or less.
Pretty much, and there's other options. We're exploring. There's no point in discussing token side of it. We've played with the token aspect of it. It comes down to something we were discussing earlier today. Does it need a token? We don't know yet, and maybe not. But we don't want to move too far away from what people are used to, both in kind of just using UX UI and also actually just the how to use it and get benefit from it. Now there may be other revenue models and ways out there, but we want to keep it simple for the time being, because I think that one of the, just going back to what you said before, one of the problems with the DePIN community is that there are a lot of projects and platforms that industry gets confused, right? So you're trying to kind of either get into an existing market or create a new one, as we discussed. And I think that people get a little bit put off by how complex some things are, either to use or just in terms of what they represent or what they actually do. And people maybe, people that could maybe use certain technologies in the DePIN space fail to see it because things just, and that's a historic thing with crypto in general, right? Because people saw it as difficult, using a wallet was difficult. And so we want to kind of take all those, I know it's been addressed throughout the whole ecosystem anyway, but that's certainly something we want to kind of retain, just that familiarity.
Maybe to your point, Daniel, on who is the customer. So when speaking to investors, they look at a lot of DePINs and they're saying that many of them actually build for other projects, for other crypto projects in order to serve them. But there's very few DePINs that actually build applications, and investors are saying we'd want to see more applications. How do you answer to investors on such a challenging question?
I mean, the applications of our infrastructure. I mean, if you're talking about the uses of it, yeah. So I mean, the use of what we're building is almost, to be honest, we've struggled defining that in a short sentence because it has a lot of application. Whether that's on the device side specifically, because as we kind of alluded to, you're looking at. There's two sides to what we're doing. We can service the industrial side, the industrial IoT, or even the extended IoT side, where DePIN kind of then falls in some regards. And then on the cloud infrastructure side, there's whoever feels they can add, that they get added value from having that underlying attestation from the computation. So obviously there's high value. Customers or people that so in the critical national infrastructure side of things, or just critical infrastructure or national infrastructure. We talk about telco and stuff, but actually it goes across the whole. It spans anything. So even like I think I mentioned before, even if you're running nodes or VMs where you want to protect for key management, and so look at all the platforms that rely on key management. It's not insignificant. So that's just one use case. So it's quite hard to narrow it down into one, and that's something we've tried to focus on to narrow it down. But actually, there's a lot of use cases, and we're learning some more as we go along and speak to potential partners and investors, as we go. To be honest.
And I think it would be very interesting that what the technology that you're building became the standard as well, right? Because I spent a lot of time talking to blockchains, for example, the ones that are focused on DePIN. It was like IOTEX, Peak. Each of them are building this own version, and then it becomes quite complicated when you have to each one have its own proprietary technology. It would be better to have a standardized that is not necessarily connected to a blockchain that you can use for blockchain Web3 and Web2, whatever you need, right? I think that's a valid angle to look at as well. One question for you now. If you managed to build this massive supply in Taiwan or in Taipei, because there was a clear need, right? Maybe it's not going to be as easy to build the same technology or the same infrastructure here in Zurich because people have this perception that the quality of the air is beautiful and it's flowers everywhere. How like with everything that you, because I know you don't come from the Web3 or DePIN, could you see a world that the technology that you guys build could be implemented into the Web3 to really expand this network all over, Switzerland and all over the world, right?
Yes, totally. Like one thing which I learned today also was the incentivization part is quite interesting, because for some people it's more about they just want to do it. For others, maybe it would be interesting, if there are more frameworks or infrastructures about data monetization, or like how to bring people in so that there's value for everyone, not just for one party or one stakeholder, but for everyone. And I think that somehow also helps because, like I'm coming from research, so we also think about more about how to impact policy and things. So I think even the governments would be interested in that because you have this infrastructure which can complement the existing network. So you are somehow creating this public-private partnership where you have them, like the government, the policymakers, but then you bring this DePIN infrastructure with people where they want to use these devices, but you want to motivate them more by looking into this thing. And one of the other things which I think they are already doing very well is the security and the data thing, because for example, when you have so many devices in the field, you need to update the firmwares regularly and you want to make sure that it's correct one and it's not being corrupted. And once you have something which can be run on device or where it can be verified, I think it's a great alternative.
Yeah, I think you made an excellent case for private-public partnerships because we see it quite often that governments say we don't have enough budget for actually this and that initiative and we cannot support them. But actually spinning off DePIN networks and being able to raise capital for actually productive uses is a very good use of those DePIN tokens.
Yeah, no, exactly. I think questions, I'm just going to say one word, and maybe make sure to check the DePIN Hub podcast for next week, next Thursday, which is going to be security on quantum computing. So that's going to be another interesting topic, but that's for another time.
Yeah, I saw quite some hands rising from the audience. You were very first, I know.
Thank you very much. My name is Valery, CTO of 1KX, and my question is to DePINity guys. So do you see ZK as really the driver for verifiable compute for sensor space and DePIN space, as opposed to, let's say, various consensus models or TE? And I have a second question, like if you're doing ZK, you mentioned the ARM instruction set. Are you actually proving ARM, or is it like you have execution on ARM, but then you have a separate kind of an artificial instruction set of a kind that works in parallel? It's more of a technical question.
Okay, so thank you very much. We're not doing anything with TEs. We're essentially at that opcode level of the processor. And the reason is because with a TE, you assume trust. We wanted to assume there's no trust, no environment. And from that level, because we also don't want to have to use TEs in ESP32 chips or small IoT devices. We want to be able to put it straight onto the device, update the firmware with a small bit of code, and that's it. Regarding your first question, it's the combination of the arithmetization and the function hiding zero-knowledge proofs that we're using. We're not using input hiding. Essentially, we're proving the entire function. So that came out of Stanford about 3.5 years ago. Professor Dan Boneh wrote a paper on function hiding functional commitments. So we took that paper, and along with the arithmetization, it allows us to prove that the program is in its entirety functioning as it's intended without giving away any details of the computation. So that for us is the key to verifiable computing. At that level, without T's or secure enclaves or whatever, being able to prove that based on the opcodes, the program is traversing the paths it's supposed to. So for example, if you have an injection of malware into the firmware, the proofs will fail. And this is different for different chipsets. So if you have different instruction sets for x86, ARM, et cetera, we modify our code to be able to accept that instruction set. So for us, the initial starting point was with the ESP32 chips, because they're in literally every IoT device, right? For our partners with the hydrogen project, we needed to add more to our code to handle the ARM instruction set. So as we grow, we'll add x86 and whatever else needs to be done. I hope that answers your question, both of them. Yeah, thank you.
Renato speaking. I'm from the industry, so I have a kind of traditional background similar to Belimo. And one of the key elements for a successful use case is to have a kind of proven, reliable, proven, credible solution elements. You don't need complete solution, but you need at least some element that you can build like a Lego castle. So my question is, now for Penidity is, have you considered taking the DePIN element of your product and make it open source, widely available, and then collaborate with a key supplier market manufacturer to ensure that your SDKs are embedded by default? That could potentially boost your business case, boost the adoption of the creation of demand, because it's out of the box, that option. And then on top of that, you sell your SaaS services out of the box.
Hanato, is that your name? Yes. Hanato, if you come up to me afterwards, I will show you the open source GitHub repository and all the mathematics on the website. So,
cool. Thanks.
Thank you.
So we need to go to beer and wine soon. Woohoo. Any other questions from the audience, or maybe you want something?
Yeah, Dennis. So I come from blockchain community in general, and probably been there for quite a long time. So if I recall with ICO times, 2017, 18, there was a slogan, data is a new oil. So, and this is exactly what we're talking about today. Probably, Miha, have you ever heard of any blockchain project that managed to get paid customers from that time, like Ocean Protocol, maybe tokenizing like medical data or energy consumption data, who managed to get from this big slogan and give us money for ICO to real monetization of their promises?
Yeah, absolutely. So I think from the ICO time, Ethereum has proven its use case, and it's still on. And I think Ethereum produces a lot of money, so has a lot of revenue. You can still consider that Ethereum might be somehow categorized as a DePIN, but not really. But I think this is one of the biggest examples out there. In terms of more recent examples, I think we have Helium that has proven to have product market fit. And in terms of becoming better, cheaper, faster than the traditional businesses, actually you've seen that with the Helium mobile subscription, they were able to offer those subscriptions in the US for as low as $20, versus if you have a subscription by Verizon is around $100. So I think that's one of the examples that, actually are here to stay, where the costs of for the end users are going down drastically.
I think also Hive Mapper, like they don't really publicly announce all the revenue, but at least they're saying that they're growing, they're getting more and more revenue, and they have this car data. One thing that I also is quite interesting, it's kind of relevant to what you said. I was interviewing Amira from Solana Foundation a few weeks ago, and one sentence that we were discussing about like data, etc. And one thing that I said that I was like, okay, I need to quote this, which is DePIN is AI scraping for the real world. You know, because like we're doing, AI has all the scraping that does from all the websites, etc. And AI is going to be the same thing for the real world, because you have Hive Mapper, Rover, there's so many projects that's trying to understand the real world into data, and this data is going to be used then for training AI in the future. So I think that was a good quote.
Well, what a good quote from Solana, especially because they are one of the main layer one supporting.
That was my quote, just
so very good.
just in case. But yeah, but it was like a very interesting one, and Okay, we're just brainstorming about this stuff, and yeah, data. I think it's the new oil, but it needs to be verified, you know, and trusted. Well, I think that's it, right? Thanks so much for joining, for sticking all this time. Thanks for the organizers, and I'll let you finish.
I don't have much more to say. Buffet is open. There is some food. There is some drinks. The panelists will stick around if you have any further questions. And just from my side, thank you so much for joining this event and coming to Trustware. And I hope to see all of you very soon. Cheers.